Portal Lab, Anywhere, Anytime, a success story at Siddhaganga Institute of Technology. In conventional lab, we used to have a very restricted time, and there was a tedious measurement techniques available, and the scope was limited to only the conduction of the given experiments. But using portable lab, students have unlimited time, and there is a peer-to-peer learning possibilities, and they can do in-depth analysis of the circuit and the concepts. We shall consider the case study number 1, where we have a Wien bridge oscillator. On the left hand side we have a conventional Wien bridge oscillator circuit, where if we keep the voltage gain of the circuit more than 3, system will give a sinusoidal output of a specified frequency. And on the right hand side we have an innovative circuit where we have an input also given. As we can see, the characteristic equation has AV value which decides the stability of the system. If the voltage gain is less than 3, the circuit will act like an amplifier. If it is equal to 3, the system will be oscillatory. If the voltage gain is more than 3, system will be unstable. So that can be seen at the closed loop pole position versus the value of the voltage gain. For a gain of 1.5 and 2, the poles are there onto the left hand side of the S-plane, indicating system is stable. If the gain is equal to 3, the system has poles onto the image axis, where it will going to give a oscillatory response. If the gain is more than 3, the poles are there onto the right hand side of the S-plane, indicating the system. As long as the gain of the amplifier is less than 3, the system will be acting like an amplifier. If the gain becomes equal to 3, the system will start oscillating with a frequency as 6.3 kHz, even though the input of 100 Hz is applied. When the gain is just equal to 3, we are getting 6.4 kHz even without the input waveform. If the gain of the amplifier becomes more than 3, now you can see on either positive or negative peak, it will be get clipped off. Now the system is in unstable condition.
System is acting as an amplifier, input wave, inverting amplifier. Fine. Now, if you increase the gain, we are going to get the oscillation.
Now it is oscillating. What is the frequency of the oscillator? Okay. Even though you applied a 100 Hz, 200 Hz input signal, whereas the output signal is at 7.7 kHz. Now it is the amplifier is working like oscillator now.
Now the closed loop poles are on the imaginary axis.
On the image axis.
First case as an amplifier, they are in the left side.
They were on the left hand side of the spectrum.
Okay. Now if we increase the gain too much,
okay,
it is going to act as a square wave generator.
Can
it is an amplifier.
From the left side of the plane, this plane will move on the imaginary axis towards the right side.
Now it is on the image axis.
Yes, sir.
Can you see white is amplifier? Okay, gain is left hand. Okay, from this, so no need to measure.
We have considered demodulation of FM signal using PLL. This is considered to be one of the complicated experiment, as students find it difficult to find out the lock range and capture range, which is essential to demodulate the FM signal. But using portable lab, with the use of Bode analysis, it is very easy to find the lock and capture range of the PLL, and it has also given scope for students to vary the Bode plot of PLL for a particular time constant of the loop filter. This is for a reduced time constant of the loop filter. This is a demodulation of FM signal. FM signal carrier frequency 50% modulation index. We are getting the demodulated waveform. As long as the frequency swing lies within the lock range, we are getting the proper demodulation. You can see now we are still getting the demodulation. The modulation index is increased such that the frequency swing goes outside the lock range. We are unable to get the demodulation. It can be also seen by changing the carrier frequency to a larger frequency, where the frequency swing goes outside the lock range of PLL. We are unable to demodulate the waveform.
Goes up to almost 200 kilohertz. So it will capture frequencies from 112 to almost 200 kilohertz. So can you show modulation of FM signal? So this is your FM signal. And the carrier frequency 70 kilohertz. Okay, now this is to 10%. Amplitude will change. Make it 10%. If you make it 50%, let us see. Now it is fine. If you make it 70-80%, if you make it 80%, why you are not getting now? You just expand it. Why you are not getting now? Okay, now the carrier frequency has gone out of the capture reject cable. Change the modulation index. Make it 50%. It will go out of the lock range, not demodulate. So up to 30%, make it 30%. 20% of it is out of range. So 20% is fine. Make it 20%. 20% you can become automated. Change the carrier frequency to 100 C. Still going out of the range. So it is very much necessary that it should be within the lock and key. Okay, it will track it so that it can easily demodulate it. Okay, can you show me the demodulated waveform? So the demodulated waveform. Go to the modulated signal. Here you have modulated signal. Can you demonstrate change in the frequency of modulating signal? Change the frequency of modulating signal. Because it changes. It is tracking. Up to what range it will track? This network it will track. Is it possible to change that range? Okay, loop filter will want to decide what is the capture range. What is the advantage of having larger capture range?
We can track the
Signal.
Anytime, so that we can learn the knowledge. Actually, when I was in a first year, and some concepts are very clumsy or very confusing to me. After the introduction of this etiquette, due to the lab in the etiquette, doing in home,
we'll go home and do practical and see the practical waveforms. It is so portable and we can do anywhere, anytime.
Etiquette is a very portable device. You can use it wherever you want. Even if the lab is closed, we can take it to our home and we can use it there. During the exams, we can use it because the labs will be closed. We can use it in the home and we can practice it.
Portable lab is useful because by using portable lab, we can spend our time when we are free. We can spend our time doing some experiments, learning some.
This education only for lab purpose. We are using it for what they are teaching inside the class. Without that, we are trying to do that circuit also inside the home, and us to do in home easily so many projects, so that those things which we can't do in lab we can do in home. So this portable etiquette is very useful.
Integration of courses like control systems in electronic circuits, introduction of the flipped classrooms has given lot of confidence to students in analyzing the circuits, and they are cementing their theoretical concepts while doing the experiments. And because of all these things, students now think of challenges in real life, solutions to real life challenges as a group activity. Future plans are virtual lab, anywhere, anytime, anyone can access these hardware labs. One more innovative project what we have is the interactive lab, where students will be guided by the circuit to get the desired output. The circuits will actually guide the students to get the desired output. This is an innovative lab we are thinking. I thank all of you for your kind attention.